All right, in this video, we're going to talk about section 5.4, dealing with the definite integral. And in this section, we're, we're going to be using the properties of definite integrals to evaluate them. Okay. Now, in previous sections, sections 5.1 and 5.2, we were dealing with what they call the indefinite integral. Okay. Because when we take an indefinite integral, we integrate that particular expression using some of the rules, and then for our final answer, we include what they call the plus c. This time, we'll be looking at the definite integral. So here is the definition of what a definite integral is. Here we're going to let f be a continuous function on the closed interval a comma b. The definite integral of f from a to b is denoted as this. Now, with the indefinite interval, you didn't have these two numbers here from a to b. This time, with the definite integral, you do, because now we're looking at a interval, a closed interval, a comma b, from a to b. So your integrand is still going to be f of x. But here, this a at the bottom, that's going to be the lower limit of the integration. And the b at the top would be the upper limit of integration. Okay. So it's going to be the integral from a to b of the function f of x dx. Right. Now, let's talk about negative values here, because the first few examples that I will give you deal with negative values here. And you'll be given a graph of a function y equal f of x. If f of x is positive for some values of x on the closed interval a comma b and negative for others, then the definite integral symbol, which is this, the integral from a to b of f of x dx, represents the cumulative sum of the signed areas between the graphs of f of x and the x-axis, whereas where areas above are positive and areas below are negative. So here's an illustration of this. Here we got the graph of y equal f of x, and we got the x-axis, which is the horizontal axis here. So this right here represents the x-axis here. Now, if you have areas above the x-axis, like this here, here's area B, that's above the x-axis, that's going to be positive area. Whereas if you have an area below the x-axis, like here, area A, that's below the x-axis, that area will have a negative sign. So like the integral from a to b of f of x dx would be equal to the negative area of A plus the positive area of B. Okay. So now let's look at a few examples of just this on the next page. So in this case here, we got the graph of y equal f of x on the right-hand side, and we want to calculate the definite integral by referring to the figure with the indicated areas. So here we got area A, which is going to be in yellow. That's 1.365. Area B, that's this area in red. That's going to be 2.313. This is area C. I know that's hard to see the letter C, but it's in blue. That area is 5.426. And this green area down here below the x-axis, that's area D, 1.702. Now here we're going to find the integral from b to 0 of f of x dx. That is, from lowercase b up to 0. So what I'm going to do here is draw a vertical line where b is, vertical dotted line where b is, and another vertical dotted line where 0 is. That's going to be this area from b to 0. And the only area that you see here is right here. That's area B. Now notice where area B is. It is below the x-axis. So that means the area for B will be negative. So that means, in this case, and I will rewrite this, the area, the integral from b to 0 of f of x dx is going to be the negative of area B, because area B is below the x-axis. So that's why it's negative. Now, area B has a value of 2.313. So that means we'll bring over the negative sign, and area B is just 2.313. So the integral from b to 0 of f of x dx would just be negative 2.313. Okay. All right, example 2. Let's say I want to calculate the definite integral by referring to the figure with the indicated areas here. So here we're dealing with the integral from 0 to c of f of x dx. And we're told that area A is 1.428, area B is 2.755, area C is 5.637, and area D is 1.897. So we're going from 0 to C. In other words, here's 0, that's going to be the y-axis, up to C, lowercase c, which is right here. So it's going to be this distance from 0 to C. And the only area we have here is right here, area C, that's in blue. And it's above the x-axis, so that means that that particular area will be positive. So the area from 0 to C, or the integral from 0 to C, of f of x dx, that's just going to be area C. And area C, its value is 5.637. So that means that the integral from 0 to c of f of x dx would be 5.637. All right. Here's another one. Let's say I want to calculate the definite integral by referring to the figure with the indicated area. So here is that figure. Now we're finding the integral from a to c of f of x dx. And we're told that area A is 1.518, area B is 2.55, area C is 5.685, and area D is 1.669. And we're going from the integral from A to C of f of x dx. So that means here's A right here, lowercase a here, and C is right over here. So it's this distance from A to C. Well, now we got 3 different areas that we're dealing with here. Starting at A, we got this distance that is above this area above the x-axis. That's a positive number, so that means we have area A plus, here's area B. That area B is below the x-axis, so it's going to be negative of the area B plus, and here's C up here. That's above the x-axis, so that means we'll add whatever area C is equal to. So this means here area A, since it's above the x-axis, is going to be 1.518 that's given to us, plus the negative of area B, that's 2.55, plus area C, that's 5.685. Now we're going to add those 3 decimal values together. So that means here, if we add 1.518 plus negative 2.55 plus 5.685, you'll get 4.653. Okay. So in this case here, the integral from a to c of f of x dx will be 4.653. All right. In example 4, let's say we want the integral from a to d of f of x dx. And we're finding the integral of that from a to c. And we're finding out what that area is going to be. So lowercase a is way over here, and d is way over here. So we're looking at everything from this distance, a to d. So notice that here we have an area here, that's area A, that's above the x-axis, so that would be positive. And then plus area B, that's this red area here, that's negative, that's below the x-axis. So we have the opposite of area B, because that's going to be negative since it's below the x-axis, plus here's C, area C, that's above the x-axis, so that's going to be positive. And then plus, here's area D, that's below the x-axis, so that's going to be negative of area D. All right, so area A is, in this case, 6.067. Plus the negative of area B, which is going to be 4.267. So this is negative 4.267, since that area is below the x-axis. Area C is 12.6 and it's positive. Area D, that's below the x-axis, so that value has to be negative 8.333. And if we add those together, 6.067 plus negative 4.267 plus 12.6 plus negative 8.333, this will give me 6.067. So here, the integral from a to d of f of x dx would be equal to 6.067. Okay. Right. Now, the next thing we'll look at is the properties of definite integrals here. And here are the 5 properties of definite integrals that we will look at, starting with number 1. The integral from a to a of f of x dx will be equal to 0. Because notice that the lower limit and the upper limit are exactly the same. So the integral of that function f of x dx from a to a will be 0. And number 2, the integral from a to b of f of x dx will be this. The negative of the integral from b to a of f of x dx. So here, if you swap your limits here from a to b to a, then that means you have to change the sign to the opposite. So it'll be negative of the integral of from b to a of f of x dx. Then number 3, the integral from a to b of the constant k times f of x dx. Well, like we did before in the previous videos for section 5.1 and 5.2, we can pull the constant out in front of the integral sign, so it'll be k times the integral from a to b of f of x dx. And then number 4, the integral from a to b of the sum of the 2 functions f of x and g of x, or the difference of the 2 functions f of x and g of x. So here, if you take the integral of the sum or the difference, that's equivalent to taking the sum or the difference of their individual integrals of each of those functions. So it'd be the integral from a to b of f of x dx plus or minus the integral from a to b of g of x dx. And then number 5, the integral from a to c of f of x dx, we can break that up as the integral from a to b of f of x dx plus the integral from b to c of f of x dx. Okay. So here we're going to be applying some of these properties of definite integrals to these examples. Like this one, example 5. Here I want to calculate the integral from 3 to 10 of 6x dx. And let's say we are given the following. That the integral from 3 to 10 of x dx will be 45.5. The integral from 3 to 9 will be of x squared dx will be 234. And the integral from 9 to 10 of x squared dx will be 271 over 3. So here the integral from 3 to 10 of 6x dx. Now here we can use property number 3, where if I have some constant times x dx, I can take that constant and pull it out in front of the integral sign. So the 6 will go out in front, and then that'll be multiplied by the integral from 3 to 10 of x dx. But look here, the integral from 3 to 10 of x dx is this right here, 45.5. So I'll take 6 times, now the integral from 3 to 10 of x dx is that value, 45.5. So if you take 6, multiply that by 45.5, you'll end up with 273. So here the integral from 3 to 10 of 6x dx ends up being 273. All right, here's another example. Say we had this. The integral from 4 to 2 of 4x plus x squared dx. We want to calculate that given that the integral from 2 to 4 of x squared dx is equal to 56 over 3. The integral from 4 to 5 of x squared dx is 61 over 3, and the integral from 2 to 4 of x dx will be 6. Okay. So here's what we have. The integral from 2 to 4 of 4x plus x squared dx. Well, we got the integral of the sum. We can break that up as the sum of their individual integrals. So I can write this as the integral from 2 to 4 of 4x dx plus the integral from 2 to 4 of x squared dx. Okay, so in this case, I was using property number 4 of your definite integrals. Now for this one, I'm going to use property number 3, where I can pull the constant out in front of the integral sign. So I can pull the 4 out in front of the integral from 2 to 4 of just x dx. And then plus the integral from 2 to 4 of x squared dx. I'm just bringing this down. Now, I'm going to have 4 times the integral from 2 to 4 of x dx. I have that right here. Integral from 2 to 4 of x dx, that's going to be 6. So this will be 4 times 6 plus the integral from 2 to 4 of x squared dx. I have that right here. That's going to be 56 over 3. So I can replace this with 56 over 3. Now, if I simplify this, 4 times 6 will be 24, plus 56 over 3 And I could use the graphing calculator to add those two numbers together. So if I add 24 plus, and in parentheses, 56 divided by 3, close parentheses. To change that to a fraction, I press the math key on the left side, select number 1 for fraction, and then hit enter. That will end up being 128 over 3. So in this case here, the integral from 2 to 4, 4x plus x squared dx would end up being 128 over 3. Okay. Let's look at example 7. Here we're calculating the integral from 2 to 9 of 2x squared dx, and we're given the following. The integral from 2 to 8 of x squared dx is 168. The integral from 8 to 9 of x squared dx is equal to 217 over 3, and the integral from 2 to 8 of x dx will be 30. So in this case here, the integral from 2 to 9 of 2x squared dx. Well, let's use property number 3, I believe. Yeah, property number 3, where I can take this constant of 2, pull this out in front of the integral sign. So it'll be 2 times the integral of from 2 to 9 of x squared dx. And this is from 2 to 9. Now, notice here, I don't have anything from as integrals from 2 to 9 of x squared dx. But notice here, I got something, an integral from 2 to 8 and an integral from 8 to 9. If I add those two, that would equal to the integral from 2 to 9 of the same expression, x squared dx. So I'm going to bring over the 2. This integral can be broken up as the sum of these first two right here. The integral from 2 to 8 of x squared dx plus the integral from 8 to 9 also of x squared dx. So in this case here, I'm applying property number 5. So with this, I'm applying property number 5 of those properties of definite integrals. So let's find out what we have here. I'm going to bring the 2 down. The integral from 2 to 8 of x squared dx, that's this right here. That's 168. Plus the integral from 8 to 9 of x squared dx, that's this right here. That's the 217 over 3. Excuse me. So here I got 2 times, and I'm going to add 168 plus 217 over 3. So here I got 168 plus, and in parentheses, 217 divided by 3. Close parentheses. That's a decimal, but I want that as a fraction. So if I press the math key and then select number 1, for the fraction will be I'm sorry. That's 168. Okay, so it's 168 plus, and in parentheses, 217 divided by 3. And then press the math key and then number 1 for fraction. So this ends up being 721 over 3. That's in parentheses. And then if we multiply that by 2, and then again press the math key, then number 1 for fraction, this will be 1,442 over 3. And we'll leave it as an improper fraction. So the integral from 2 to 9 of 2x squared dx will end up being 1,442 over 3. All right, example 8 is the integral from 10 to 7 of 4x squared dx. And we're given that the integral from 2 to 7 of x dx is 22.5. The integral from 2 to 7 of x squared dx will be 335 over 3. And the integral from 7 to 10 of x squared dx will be 219. All right, here's what I'm going to do here. Since I got a constant in front of the x squared, I can pull that out in front. So that means that'll be 4 times the integral from 10 to 7 of x squared dx. But notice these limits here. I'm going from a higher number to a lower number, from 10 to 7. It would be best to switch these limits here. So it'll be from 7 to 10. Usually the lower limit would be on the bottom, the upper limit would be on the top. So I'm going to swap these out. And if I do that, I need to change the sign from a positive to a negative. In this case, I'm applying property number 2. Switching the limits, and if I do that, I have to include the negative sign. So it'll be negative 4 times the integral from, this time, 7 to 10. 7 would be on the bottom. That'll be your lower limit. 10 would be your upper limit of, in this case, x squared dx. Okay, so here I'm using property number 2. So if I switch the limits around, I have to include the negative sign. So it'll be negative 4 times the integral from 7 to 10 of x squared dx. All right, so the integral from 7 to 10 of x squared dx, I have that right here. That's 219. So I'm going to have negative 4 times the integral from 10 to 7 of x squared dx, which is 219. So negative 4 times 219 will end up being negative 876. So the integral from 10 to 7 of 4x squared dx will end up being negative 876. All right, now example 9. Here I have the integral from 8 to 8 of 5x minus 4 quantity squared dx. And here we're given the following. The integral from 1 to 8 of x squared dx will equal 511 over 3. The integral from 8 to 9 of x squared dx will be 217 over 3. And the integral from 1 to 8 of x dx equaling to 63 over 2. So here we got the integral from 8 to 8 of 5x to x minus 4, 5x minus 4 quantity squared dx. Excuse me. All right, in this case here, notice your upper limit and the lower limit are exactly the same. So here I'm going to be applying property number 1. Okay, property number 1, because my upper limit and lower limit are exactly the same. Okay, so here the integral from a to a of f of x dx will be equal to 0. Since I have that right here, the limit from 8 to 8 of 5x minus 4 quantity squared dx will automatically be 0. And that's all there is to it. Okay. So anytime you're taking the integral from the upper limit to the, lower limit to the upper limit, and they're the same, that integral will automatically be 0. Okay, and that's all that I have in this video. So this should help you with the homework in this section. So that does conclude this video on section 5.4 dealing with the definite integral. So feel free to reach out to me if you have any questions about any of the problems that were presented in this video, or if you have questions about the homework for this section in my math lab.